Hello, welcome to another live Sudoku solve. Today's puzzle is Trick 17 by I want to say Tyas, maybe Mad-Tyas, I'm not sure. If you know if you set this puzzle and you see this video, please write in and let me know how to pronounce your name. And this puzzle was suggested a few days ago to me by a friend of the channel, Abdul the Killer, and I think they liked the way the grid looked because there's not much in it, and yet we're gonna be solving it. And since then, this puzzle has gotten a lot of good attention on Logic Masters Germany. It is rated by the community as 4 stars for difficulty, and I think when I just pulled it up this morning, it was something like 97% approval. And actually, because I actually wasn't familiar with Mad-Tyas or Mad-Tyas, and so I went and looked through some of their other puzzles. Somehow they have well over 100 puzzles that they've set, and somehow I haven't solved any of them, but they're all just incredibly rated. I mean, for as many puzzles as they have, I think it was very, very rare to see something with a rating below 90% in their published puzzles. So clearly just a great setter, and hopefully this puzzle will be fun. So let's get into the rules. So a few standard rules. I've got a little killer clue in the corner. So these 9 digits, they can repeat, but they have to add up to 39. So that's a little killer clue. I've got these V's. You can think of these little 5 cages. So the 2 cells surrounding the V will add up to 5. And these black crop key dots we've had a number of times already. The 2 cells surrounding the black crop key dot have to be such that one is double the other. So I could have 1 and a 2, a 2 and a 4, 4 and an 8, or a 3 and a 6. And it doesn't matter which one is larger than the other. Either way is fine. And then there's one more constraint here, which is not marked in the grid and is just described. And so I'm going to fill it in eventually. But the extra constraint which makes this puzzle work is that in each box, they say marked box. I assume that means the normal 9 3x3 boxes. In each one, the 4 corner cells have to add up to 17. So you can think of this as like a disjoint cage where these 4 cells have a pre-specified sum, 17. So those are the rules. I'm just going to restart the time because it's been in my computer for quite a few minutes. And let's... so the first thing I'm going to do actually is just mark all of these cells in the corner so that I remember about that 17 sum, because otherwise I'm just going to forget, and clearly that's kind of most of this puzzle. There's not many other clues going on. So these gray cells, in each box will sum to 17. And then thinking about these boxes with a V in it, I've got 17 in the corner, 5 here, that's 22. That leaves 23 in those 3 cells. The only way to get 23 from 3 digits is a 6, 8, 9 triple. I can do the same thing down here. I don't think right, so 39 is a little bit less than average for 9 cells, right? So the average cell digit is 5. So 45 would be exactly average. And yeah, I don't think there's any way to restrict that meaningfully. So when I read the rules of this puzzle, I thought immediately we're probably gonna have to do set, and that is, I think, what we're gonna do. So as I try to think about how to do the set here, I'll just kind of explain briefly what it is. So the idea behind set, which is short for set equivalence theorem, something like that, is that I can think about groups of digits that I know are the same. So for example, if I highlight this as blue and this is blue, then I don't know where these digits go, but I know that these are 2 sets of the digits 1 to 9. And I might augment that by saying, well, let's call these digits orange and these digits orange. And that's also two sets of the digits 1 to 9. Um, and so the blue digits have to be the same as the orange digits. And then I can look at the overlap of those. And so why that's useful is I can look at the overlap and get rid of them. And when I do that, I'm now left with kind of disjoint sets, orange and blue, where they don't overlap. And even though I don't know exactly what the digits are, I don't know what these 6 digits are. I know that the 6 digits in blue are going to be the same as the 6 digits in orange, um, because I've kind of systematically taken away digits that are the same from two sets that are otherwise equivalent. And I mean that's not going to be useful. This is just basic Sudoku, right? That these 6 digits have to be the same as those to fill the cage correctly or the box correctly. So that's not the right set, but it'll be something like that. And the reason when I read the rules, I thought, oh, it's got to be a set puzzle, is these 17 sums, right? So another way that set can be useful is when I take away digits, I can take away overlapping digits where I'll know that whatever's left are the exact same digits, but I can also take away digits that are the same sum, that I know to be the same sum, and that will let me say not that the digits that are left are the same, but that the sum of the digits that are left are the same. So I'm trying to think about ways that I can get kind of groups of 17 one way and another. So for example, I might do something like this versus this. And if I do that, well, I can get rid of the ones that directly overlap, right? Those won't be useful anymore. But I can also get rid of these, right? Because I get some, I don't know what digits they are. They may not be the same digits, but I know that the sums are the same, right? There's in each of those groups, the orange and the blues, I've got 2 sets of 17, so 34, and so the sum of those is the same. And so now I know the sum of these oranges are the same as the sum of these blues. So I don't know how it's useful, but that's my first try at finding something here. That doesn't seem to work. Or I mean, this might be helpful at some point because, right, these are both pretty high. This one's at least pretty low. So maybe I'll end up with these blues are going to be, one of them will be, I guess 7, 9. That could be quite high. Yeah, I don't quite see what to do with those. Let's try something else. So maybe I just need to think more broadly. So what if I do all the rows with the grays in it? So I'm just trying to think of ways that I can kind of encompass all of these gray cells because that's where the 17s are. Okay, so now what do I want to get rid of? I kind of don't want to get rid of gray cells because those I know what the sum are. So what if I do something like this and get rid of all those? What does that do? Okay, so that's blue. And I can get rid of the overlaps. Does that give us anything? Okay, so I've been trying to think because when I did this, I've got 6 sets of orange, right, and only 3 sets of blue. And I'm trying to think, well, how do I add more blue in a way that kind of makes sense and kind of preserves these 17s? But maybe I don't have to. So if I were just doing this on my own and not recording it, I would just pull out a calculator. Let's see if I can do it without a calculator. So what am I thinking? I'm thinking about, so these blue digits are kind of the same as the orange digits, except the orange digits have some extra, right? So these orange digits have 3 extra sets of the digits 1 to 9. And I know the sum of the orange digits, right? Because the orange digits are just all 4 of these squares. in each of the 9 boxes. And so those orange digits are going to add up to 17 times 9, which is 153. So my orange digits have a sum of 153. And I also know the difference between the sum of the orange and the blue digits, right? Because the orange digits started out as 6 sets of the digits 1 to 9. The blue started out as 3 sets of the digits 1 to 9. And so the difference between them had to be 3 sets of the digits 1 to 9, or 135. So 45 is the sum of the first 9 digits, times 3 is 135. So the difference between the blue cells and the orange cells at the start was 135. And then I took away a bunch of overlapping cells where the blue and orange overlapped. And by doing that, I made the sum of blue smaller, but I also made the sum of orange smaller. And I did that by the exact same amount. And so the difference has to be maintained. And so that difference is still 135. And if we said the orange is 153, so 153 minus 135 is 18, which is quite small. And so, yeah, in fact, that's the minimum that these 9 blue cells could be. Because the smallest I can make these, right, is 1, 2, 3 in each column, or each row. I do the same thing in each column. And 1, 2, 3 is up to 6. If I do that 3 times, that's 18. So, yeah, so that's just, that's it. That's the trick. And that's the trick. So now what? Now these V's, right? So these V's are, the other side of the V is a 4. Whoops, in both cases. Why? Well, because on a V, it's got to be the digits 1 to 4, right? It can only be 1, 2, 3, or 4 because it's got a sum to 5 with something else. And in this case in the column, and in this case in the row, 1, 2, 3 are taken. So those have to be 4. So those are going to get paired with 1. That's going to put a 1 in the middle and make the rest of these 2, 3 pairs. And let's go ahead and get rid of that blue. Well, actually, no. So I almost got rid of the orange too. I didn't actually use the fact, like I didn't subtract any 17. So actually what's true about the oranges is that these are also, the oranges are 2 sets of the digits 1 to 9, sorry, 3 sets of the digits 1 to 9, and then 3 extra 1, 2, 3s. 3 extra 1, 2, 3s. And I'm trying to think how that might be useful. Not sure. Well, these I can just fill in, right? These are 2, 3, 5, 7. Maybe I will get rid of the orange because they're marked by gray. So I'll try to remember that the gray digits are 1, 2, 3, 3 times, and then everything else 3 more times. And just, yeah, I'll hope I remember that if it ever becomes useful. Okay, let's see. So now what? What can I say about, this is not 2, 3, 5, 7. Errant marking there. So now, okay, so 4s meet here. So 4 has to go in a corner cell here, and 1 has to go in a corner cell here. So what's left? To get to 17, I already got 5, so I need 12. So it's either going to be 3, 9, or 5, 7. And this can't be 5, 7, or 9. This is 1, 3, or 4. That makes, if it's 1, it's 2. If it's 4, it's 2 or 8. If it's 3, it's 6. Can I do something like that here? So here, actually, well, this digit can be 1, 2, or 3. So this is 4, 6, or 8, which makes this 2, 4, 8, or 3, but not 4. And the 4 means that's not 8. Actually, that's true. So I get this one. I should have, when I filled in the 1, 2, 3, I should have immediately, I should have put in my brain the fact that means 1, 2, and 3 don't appear anywhere in these white cells except where they're marked, right? And all the white cells, 1, 2, 3, are taken. And so if it's marked, then it can be, obviously is what's marked. But if it's not marked, it can't be 1, 2, or 3, because those are taken all in all the columns and rows that are white. So in this, let me think about what that means. That means that whatever's here, the other one has to be here. The other one has to be in the corner. 2 is not in the corner, right? Because I can't get to 2, whatever, 12 here. So 2 is here, and 3 is in the corner with 9. So these are not 5, 7 as that extra 12. That's 2, and that sorts out the 2s and 3s. That's not 2. Now what? So can I do, okay, I'm thinking about these squares now with that in mind, right? So in this box, 1 is in a corner, 2 is in a corner, and then that I need a 12. So 3 is taken, so it's either 4, 8, or 5, not 12, 14. 14, it's either 5, 9, or 6, 8. Here. Right, this one was 12 because it's 1, 4. This one's 1, 2, so it's 14. And then in the 1 here, I've got 2 and 3 for sure in the corners. And then that's also 5, so that's also a 12 I need. 3 is taken, so that's also 4, 8, or, well, no, it's different. 4, 8, or 5, 7. This was, it was 3, 9, or 5, 7, but the 5, 7 is gone. It had to be 3, 9 because I needed 3 in the corner. Let's just make these essential marks. And then, okay, so in this other 3 cell, let's do all the 3 cells at once. I have a 1 and a 2, and then either, let me get rid of this one just because I know I have a 1 and a 2, and then I need 14 more, so either 5, 9, or 6, 8. And then in the 2s, I have a 1 and a 3 for sure, and then something that adds up to, sorry, I said 12, I think, again before, but 14 is what I meant. Here, I've got 1 and 3, that's 13 left, so that's either 4, 9, 5, 8, or 6, 7. This one can't be 4. Okay. In the 3 squares, I can't have 4 in the corner, so I have to have 4 in the cross. And in both of these cases, at least, 4 is missing here, so it's got to go here. And it's missing here, so it's got to go here. Which means what? And then here, 4 is in one of these corners. It's not as helpful. So 4 is gone. Okay, so 4 is gone here and 4 is gone here, which means 4 is in the corner here. So that's actually, now I know that's a 4, 8 and not a 5, 7 for the 12 extra. These aren't for her. But these could be 4, or 4 could be here. Well, 4 is not here. So 4 is either going here in the cross or here in the box. Okay. What about this diagonal clue? So I've got 39 minus the 3 ones is 36. So I've got an average of 12. Oh, and a max of 12 in each of those. So these actually do add up to 12. These can't be 2 or 3. So, I mean, the 12 is the short end. Basically, if you take the max that this could possibly be, it's 5, 7 in box 1, 4, 8 in box 5, and 5, 7 in box 9. That adds up to 36, and the 3 ones makes 39. So the max, if you do the max, it could be that gets us what it has to be. So that has to be right. And that gets rid of 5, 7 the other way here, and 4, 8 the other way here. 4, 8, 2, 3, 4, 6, 8. I almost have a quintuple there, but I need something else. Okay, what about here? No. Okay, what's next? Well, these, 2. So if this is 2, there's 2 over here, 3 over here, 3 over here. So the 3 and the 2 are kind of in opposite sides in these. I'm kind of grasping at straws here. Oh, here, I know what's in the corner. So I know, if I know what's in the corners, I know what's in the center. So this is therefore 5, 6, 7, 9 in the cross. That's weak sauce. So one of these has to have an 8 in it. I'm not sure how that. Can I do something in the 6, 8? These 6, 8, 9s feel kind of important. I'm not sure how yet. 2, 3, 2, 3. No. Sorry, I'm just a little bit of a loss for what comes next. Right, 4 here could go in the cross, or it could go in the corners. Either way is fine. Oh, this can't be 4, 8 because of that 4, 8. So that is 6, 3. That's probably going to be quite helpful. That gives me 2 here, 3 here. These aren't 2. These aren't 3. That's not. Those aren't 3 means that's not 6. That's 2, 3 here. These aren't 2. 2. That's not 2. So that places a 2 there. Can I just place all my 2s? I've got 2, 2. No, I'm going to end up with this kind of 3-way set of 2s. Okay. I'm going to turn that into a corner mark because now it actually, well, no, it doesn't mean anything. And I'm going to, well, I'll just leave it. Okay, what about 3s? 3s, I've got a bunch. No, one of these. One of these. Actually, these aren't 3. Yeah, but I get the same thing with the 2s as the 2. So basically in both cases I have 3 boxes where it's almost like kind of just a remaining X-wing, except well, these aren't 2, except that, all right, with the 2s it kind of goes around a corner, and you end up with, right, once I place 1, 2, the rest will fall. Same thing with the 3s, just in different boxes. Can I do something similar here? If this is 4, 8, does that cause a problem? Not so much. 1, 2 would make this 3. Make this 3. I don't see a problem with that immediately. Okay, so what else has to go in the crosses here? So I need a 7 in the cross for the 3s. 7 has to go in the crosses. And 7 has to go in the cross here because the 6 is here. I don't know how that helps. 7 has to go in one of these because it's not up here. I mean, yeah, I'm really struggling a bit to see where to go next. These are all high digits. Oh, I know what these are. So what's left here is 5, 6, 8, 9. Oh, I almost have 5, 6, 8. So that means 7 is here and not here. Wait, no, I did that wrong. It's 5, 6, 7, 8. So that's worse. Yeah, no, that doesn't help me. Doesn't help me. What about that observation I made before so 5 and 7 appear twice here now. So there's kind of one more 5 and 7 somewhere. The 7 has to go in a 3-centered box, right? Because the 2-centered boxes have 1 and 3 in them. If I also added 7, that would be 11. Oh, wait, no. Is it the other way around? Is it a 3-centered box? Oh, yeah. Okay. The 3-centered boxes have 2 in the cages, and those can't have a 7. So maybe I'll just mark that. 7s have to go in the cross in the 3-centered boxes. I need one more 7. So of these 2-centered boxes, exactly one is a 7, and not this one, because I know what those are. Is that helpful? No, I think that comes from Sudoku anyway, like kind of more standard, because I can only have one possibly in this cross, so one's going to go in the corner, and then wherever it goes, well, I guess it could have gone here and here. Oh no, because that would break this, I guess. Well, yeah. So I'm not sure if that's helping me. What about 5s? Fives could go in so maybe that's actually more interesting because there's so many places 5 could go. Not there. But only one of them actually has a 5. So all these, only one is a 5. Oh no, whoops. All of these cells, exactly one is a 5. And so the rest have to go in the corners here, or the rest have to be in white. It's not immediately obvious to me how that's helpful. Well, actually, no, 'cause I was gonna say that means that 5 has to go in the center here, but that's not true because five could easily go in the. My thought was, if only at most one of these, say, could be a 5, then that means there's at most one 5 in. It didn't make any sense, so I'm not even gonna bother repeating it. It's silly. So what's next? We got 1, 4, 9. Can I use something with 6s? That's not 6. 6. That's not 3. Oops. These are not 6. Oh, hold on. 6 in a 3 cage. 6 went with 8. No, 6 went with 7. So these aren't 7. So there is a 7 in here. Not sure what that means. Not 6. Right, so the X, so in addition to the 3s, there's a 1 in either 4, 9, or 5, 8. Right, I don't know which way though. So the other one goes here. And then here, there's a 4 going down. This could just be 4, 7, I suppose. What could it be? If the 7 is here, that makes this 7 and this 7. Yeah, that all seems to work. That all seems to work. And that means our 1, 7 is in the corner here. Yeah, no, that's fine. Maybe it doesn't work the other way. If those are 7, then I get a 7 here, I get a 7 here, and here. Oh, that still makes this 7. Interesting. Interesting. This is 7 either way. So I was thinking, what happens if I, in this box, if I make, the 7 is either going to go, in this column or in this row. If it's in this column, then that directly puts the 7 here in box 8. But if the 7 is here, that eliminates it from here, that puts it here, which eliminates it from here, that puts it here, eliminates it from here, that puts it here, and that puts it in here in box. That is so strange. And that makes 7 here in this. Wait, does the 7 end up here either way? That would be wild. Hold on. If the 7 is here, then it's here. And since 7 is here, then it's in the corner. If 7 is here, then it's here, then it's here, and then it's in the corner. Oh my goodness. So this is 6, 7. The thing that's not 1 or 3 is 6, 7 kind of either way. That is so... What? I'm trying to think about why that's happening. Like, is there... I mean, the reason I want to know if that's happening is there... Can I think of a way to make that easier to see for other numbers? For other numbers. Or it's just... No, it's just at this point, I've already ruled out 7 from the corners in all of the other... boxes. So 7 had to go here. Yeah, 7 was... Because 7 was in the crosses by necessity in all these other... right here is this... Let me back up a step. 7 has to be in the 3 centered boxes because I can't do 1, 2, 7. Right, that makes 10. I would need another 7 to get to 17. 7 can go in 2 centered boxes, but in this case I had the 6 from the crop key dot, that put the 7 there. In this one, I had the 4, no, what did I have? I had these pair of 4s leading in here saying a 4 had to be in here, and that got rid of the 7. And then in this one, I had this 4-8 possibility. No, why does that have to be 4-8? Oh, same thing, the 4s. The 4s mean this. I had to have a 4 in the corner. I got rid of the 7 here. So the only box that could have a 7 in the corner was this 2. And so if I have 7 kind of in the crosses everywhere else, that's gonna... You can use Sudoku then to wrap it around and get here, but it's basically just another way of looking at that set observation from before. Sorry, you probably didn't want to hear me explain all that again, but I found it interesting, so I said it. Okay, so now I know what's in the center here. This is not 3, 4, 5, 8, 9, 6. So now I know the 7's there, and then one more from that big jumble of numbers. Okay, and then this is either 4, 9 or 5, 8. It can't be 4, 9 because of this 4. Okay, so this 4 now is saying this has to be a 4 in the corner, and therefore it's 4, 9 in the corner. It's not 5, 8. 5, 8 is here. That gets rid of 5 here and here, but 5 could still go this way. 5 is definitely one of these. So these are not 5. So 5 is definitely one of these. I think it's going to happen a lot where we get this cross pattern. Now, oh, and here, 6 makes this. That's been, how long has that been there? I've had this 6, 8, 9, that makes this. 4, 5, that has to be the 4, that has to be the 5. That's not 4. 5 is here, so 5, 9 is not the one in the corner. It's 6, 8. 9 goes with the 7. 9 comes out of here. Wow, I think I was making this too hard by not seeing the very obvious 6 makes a 6. Sorry, continuing on. No, it's at the end. No, 8 gets rid of 8 from here, and 9. So this is 5, 4. 4 is not here. That's an 8, 9 pair. Now these can't be 8 or 9. So this is 5 with either 6 or 7. This is now 4 with either 6 or 7. Did I run out? Maybe. What's in left here? 5, 6, 7, 8. What's left here? Also, no, 6 is gone here, so 6 has to be here. I can go the other way. So 6 is, but 6 can be in the corner still. Okay, so, okay, but that was a lot. That I think that I feel like that was a big moment, which has just been sitting there. I've got 149. No, one of these is 8, but I don't know what that does. 4, 8, 2, 4, 8. I'm just kind of trying to do normal Sudoku now with what I've got pencil marked. Is it with this dot? 1, 2, 3. I tried this before. 4, 8, 6. 4 would go down here. I say. What is the way forward? 3, 3. Oh, can I? Am I like? No, I still have this 3s and 2s. Yeah, I still have those same 3s and 2 patterns. 3 and 2 patterns left. 4 is down here, but I knew that from Sudoku. 4. 5, 6, 8, 20. I still don't know what's in this corner. And I still know it either of the 3. So maybe I should start counting digits again. So 5 and 7 are, no, 7s are done. 5s are not. Here's a 6 and an 8. Here's an 8 and a 4. Hold on. Let's do it one at a time. 1, 2, 3 is just kind of done by virtue of putting the 1s and 2s and 3s in all the boxes that don't have them in the center. 4, I need 3 of them. So I've got 1 in box 3, 1 in box 5, and 1 in box 8. So my 4s are done. 5s are done. I've got 1 in box 1, 1 in box 9, and no, so they're not done. 5 isn't, so I need 5 in one of these boxes. I think it's just going to end up being, I mean, I can, because these are the same, I can tell it's going to be, one has to be 5, 9, one has to be 6, 8. But let's just make sure. 7s are done, right? 7, 7, 7. Did I skip 6s? 6s, I have 1, 2, and then whichever one of these has the 6 will be the third. 8, I've got 8, 8, and then again the third from here. 9s, I've got 9, 9, and then the third from here. Yeah, so whichever way this goes around, I've got one of each between 5, 9, the 5, 9 pair and the 6, 8 pair. I don't know if that helps me. I don't know if that helps me. So this 5 points in here. 5 could be in the corner, in which case it's here. In which case it's here. That's fine. Or 5 could go in the center and would go here. And then I get 5 here. And then I would need 5 in a corner here, which would also be fine. What to do? What do you do when you're stuck in a Sudoku? It's probably something simple that I'm just not seeing. I mean, simple, not really simple. Something. Hopefully, it's something like this 6 that I just couldn't see. What if 6 were here? Right? So if 6 is not in the corner here, then 6 is here. That puts 6 here. 6, oh, that breaks. Does that break? Hold on. This is a pair of 6s here. So, and 6s, so we have 6 in, no, we have 6 in these cells here, and in these cells here. and in these cells here. So I'm trying to think of the more kind of classical Sudoku reason this might break. And oh no. No, I had it backwards. Yeah, it breaks if they're both out of the cage. It breaks if they're both out of the cage. But of course, they're not both out of the cage. Oh, but, well, no. And these sevens also break if they're both the same way. Nine actually is here. Oh, here we go. Nine is not, there we go. Yep. It's because I didn't have my nines corner marked. Nine is not this way in the cross in box two. Nine is not this way in the cross in box two. So nine is in the corners, means that's not eight, that's a two. Unfortunately, that doesn't tell me this one. But it does fix my twos and threes. There's a three over here, right? Yeah, three down here. And so this is, what do we say? Nine has to be in the corner, so it's not 6, 8. 6, 8, in fact, go here. And we said before that 6 has to go here with 4. So in fact, that's just a 4, 6 pair, the 7, 8 pair. 8 doesn't go here, 8 goes here. Since this is the 5, 9 pair, this one isn't. So this is the 6, 8 pair. So these aren't 6, so that's just a 4, 7. That's not 7. These aren't 7, that's 5 and 6. Making this a 9, 7 pair. And now I think we're just done with the puzzle. We just need to do Sudoku. I feel very confident about that, right? Because this is, what is this? 8 and 9? No. Oh no, did I break it? Oh no, I broke the puzzle. Hold on. No, I broke my pencil markings. I deleted 8 from here. I should have corner marked 8 here. Yes. Okay. Whew. Those aren't 7. These are 7. These aren't 5. Okay. Let's try that again. So now these are 5 and 9, of course, because that's missing from the box. 9, 9. Okay, maybe there's another trick up the sleeve here. So 39 killer is done. Ignore the 39 killer. The 17 cages are all essentially done. So I can ignore that yet. And the Kropke dot is essentially done. So all that's left is Sudoku. It's just Sudoku. I just have to figure out the Sudoku. So 3s are done. 2s are done. 1s have this pattern I'm never going to get. Let's try 6s. Not obvious how to resolve those. What, 7s? Just the 1, 7. Okay, 7, but that was where it looked. 7, 8, 7. 8 makes this 4, 8. That's 1, 9 pair, making this a 5. Those are not 5. That makes us 7 and 5. That's not 7. That's not 7. That is 7. That's not 9. That's 8, 9. 8 means these aren't 8, so this is 8. 5, 8. 7, 5. 4, 7. And now we get the 1 there. 9, 8, 6. 1, 8 makes this a 9. 5 makes that a 6. 5. 1 is gone from the 1, 8 pair. 9 is gone from the box 9. 4, 6, 4. 6 makes us 8, 6. Yeah, we're just cleaning up pencil marks at this point. 4 makes us 5, 4. 5 makes us 5, 9. 8 makes us 1, 8. 6, 1. 9, 7. This is 4. 1, 6. 1, 9, 7. 9. Do I feel good? Yeah, I do feel good. Cool. That was really great. That was a great puzzle. Thank you to Mad-Tyas for setting it. Thanks to Abdul the Killer for recommending it. Yeah, that's some really cool geometry. I mean, I really like geometric puzzles, and this had a lot of that going on. These weird patterns with the crosses and using kind of um, ways where you had kind of corner marked digits looking into another box to put them in the corner. I thought that was all really great. So that kind of was the whole puzzle. So yeah, I really enjoyed it. Thanks for setting. Thanks for watching. Thanks for recommending the puzzle. If you have recommendations, please put them in the comments and I will try to get to them. So thank you again and goodbye.